Welcome to the transportation problem. Here we look into the problems regarding in the strategic sourcing. There are different warehouses to be there, and there are different market locations to which we need to buy or we need to source materials. So if you look into, there are different locations. The cost also used to be on the basis of the warehouse location and the market requirement points. So, look into this scenario. The simple problem is given: the warehouses are in ABC location and the market are in PQRS location. The nodal point are given 1, 2, 3 for the warehouses, and for the nodal point 4, 5, 6, 7 for the PQRS market. And the market total requirements are given below. The requirements are 7 for 7 turns for the P, and Q for the 12 turns, and for the R 17 turns, and for the S 9 turns. And for the supply that can be possible from the warehouses, A is 22, from B is 15, and from the C is the 8. So let us see how to design. So let us see how we can design the model for this same. So this is known as network diagram. So there are supply point, the warehouses, sourcing point, and the market is the destination point. So can you see here? It's so nicely it's representing the nodal 1, 2, 3 as ABC and the nodal 4, 5, 6, 7 as the PQRS, and the total supply quantity is being written 22, 15, 8. That is the supplying constraint by the different factories, and the receiving requirement is the 7, 12 and 79 by PQRS, and the cost of transportation from the for the different routes are also being mentioned here. So it's a simple representation of the total our transportation scenario through the this transportation model or the network diagram. So let us see how to frame the equation and to solve this. And this is the simple presentation of the same problem. Here we have given the notation A14 from the nodal 1 to the transportation, this market point 4. These are the A14, A15 from the nodal point 1 to the transportation market point 5. So this A14, A15, A16, A37, these are all the supply quantity that need to be supplied from the different warehouses to the different markets, so that at the end we can able to optimize the cost, how much quantity should be supplied from the warehouse 1 to the different market point, how many supplies should be from warehouse 2 to the different market point, that we need to calculate, look into the transportation cost in the different routes, look into the demand and supply constraints. So A14, A12, these A37, these are all my variable that we need to do. These are the objective function equations. Like all of us understood that cost in the different route and the quantity is being mentioned. CA14 is the total cost for transporting from the nodal 1 to market point 4. So similarly, these are the cost through this route from the nodal point 1 to the nodal 4, 5. So that is from the factory 1 to the market point 5. So 3A15 is the 3 is the cost. So this is the way the total cost that we need to minimize. The warehouse constraint that factory 1 can supply to the 4, 5 and 6 and 7 market points, total amount 22, and the factory 2 can supply to the 4 different market point 4, 5, 6, 7 is 15, and the factory 3 can supply to the different market point 4, 5, 6, 7, the total quantity is 8, and these are the market constraints. So market constraints, the market can receive A14, A24 plus A34. So this is the total amount the market 4 is receiving from the three different factory. 1, 2, 3 is 7, that is the requirement, and market point 5 will be receiving these three different factory 1, 2, 3. is the 12. Like this, the market point 6 will be receiving is 17, and market point 7 can be receiving from this three different factory 9. So let us solve this problem. This is the objective function for this problem. These are the market constraint that we require the amount for the four different markets. The equations for those four markets from the three different factors. So these are the warehouse constraint that the different warehouse that can. So it's not the factory. These are the warehouses. So the warehouses that can be supply the quantity constraint 22, 15, 18 from one warehouse 1, from warehouse 2, from warehouse 3. So we got the warehouse constraint, the market constraint, the objective functions. So let us solve the same problem through the our Excel modeling. If we look into the Excel modeling, we will see these are the different warehouses ABC, and to the market PQRS, and so warehouse to market the quantity in is how much quantity should be supplied. So that is being written here. Initially we can put any quantity 34, any quantity I do not know for how much quantity I should supply. So I can put some random quantity initially, and the cost in the different path A to P, A to Q, A to R is already being mentioned in the table. You go through the table. So we saw these are the cost that is already being mentioned in the different for the different path. Now we want to calculate. So the total cost is the total quantity we are supplying from one node to the other, and the cost along with. So the total cost, the sum product cost being calculated, and quantity that can be outflow from ABC, the total quantity that can outflow from ABC. So that is how we can calculate. So there is a constraint that the quantity that can flow from A is 22, from B is 15. So these are the constraint. So to optimize this, we have to find out the SUMIF formula. Just see the formula how this is the from, and this is the range. This these are the range, and the criteria that A is the criteria from factory from the warehouse A, how much quantity is being supplied that we want to calculate. So through this SUMIF, so this is for the A, and similarly the same formula, SUMIF formula for the B. This is for the B. Can you see this is for the, and similarly for the C. And the quantity inflow to ABC, if you look into the quantity inflow to ABC is here 0, because no quantity is coming to A. Only warehouses are supplying, they are not receiving. So warehouses are the supplying point, and the receiving point are the market points. So here the market point is not supplying, they are receiving. So similarly, sum if we calculated for the market point, for P, for Q, and for uh, can you see the dollar symbol is given to make them constant. So here these are the dollar symbols being given to keep them constant. So that these are the summary point that is from the, so here PQRS we is not in the supplying point, so it is 0. So net flow is the outflow minus inflow is the 6638.8, but the net outflow can from A can be 22, from B can be 15.8, and as they are receiving, whatever we are receiving, we are putting negative, and whatever we are supplying, that is positive. So if I'll go to the solver, so in solver, so if I'll put all these constraint, so the constraint that is to be minimized, this to be minimized, and the changing variables here, can you see the changing variables are, these are the my changing variables, and The constraint, if you look into the constraint, so if I'll uh, if I'll putting the constraint here, I'm re-adding all the constraints from the beginning. So the first constraint, add the constraint one, that the net flow from these three should be less than equal to 22. The factory can produce more, but they can only able to supply as per the requirement quantity. So this is the first constraint. But the net flow, that market requirement should be equal to, we cannot have, we should always fulfill the market requirement. That the region, the constraint whatever, the 17 they are the receiving, that is -7, -12, 17. So we got the equations, we got the changing variable is the supplying quantity, that is these are the changing variable, and the total cost is my objective function, so that is state objective, this is changing variables, and these are the equation constant equations, the market and for the warehouse. So now if we'll solve, so okay, then we got the solution. So A to P, A to Q, A to S, how much we can supply from the factory B, we can supply to the market R, and factory C can supply to market P and can supply to market S, and A can warehouse A can supply to Q, R, and S. So this is the way the whole demand, if you look into here, the A is supplying max 22, B 15 and 8, and here also market are, they are also, so all constraints get fulfilled. So this is the way we can solve this problem, that for the warehouse, this problem we solved it, and we got the total quantity that we should supply, and this is the final solution for our uh, problem, and all of us understood how we can go about this solution. So thank you. This is all about the simple transportation problem where there is only warehouses and market, but regarding the distribution center in between the major warehouses to the market points, like if there are warehouses, there are factory, and there are market point, how to solve that, we will solve in the next video.